Do you remember all that remainder theorem stuff? I'm going to take that remainder theorem now and I'm going to apply it to something called the factor theorem. But I want to show you something. The factor theorem is really nothing new. All it is a special case of the remainder theorem. Let me tell you what this is all about and you'll understand it. Do you remember when I said in synthetic division we have something like x minus 3 and then I said solve it and you ended up doing this and bringing the 3 over and you said x equals to 3. Now, we said that if we took that 3 now, put it back into the original polynomial, okay, and we turned around and we said that this equal to 0, we said that you would have no remainder, right? That's the thing. That was the key to the last couple of lessons. Okay, so what does that mean? Well, let's go backwards now. What does that mean with no remainder? No remainder means that, okay, we can look at it like this, and then we can put it back into this form and say, oh, that must mean that x minus 3 must be a factor. It has to be a factor of this original polynomial we called p of x. Ah, interesting. So based on the remainder theorem, we can actually use the ideas of the remainder theorem, find a number that goes equal to 0, work backwards, find a factor. Oh, I get it now. All right, so let's see. So this is what this is all about. This is if x equals to a, so in this case, we let x equal to 3, same kind of idea. You substitute it back into the polynomial, and if you get a 0, that means you have no remainder, which means the original guy, this x equals to a, so you go minus a, x minus a. X minus a is, in fact, a factor of the polynomial. I get it. I get it. I get it. I get it. Okay, so in other words, the binomial x minus a being a factor of the polynomial if and only if, when you substitute it in, you get that remainder of 0. So the neat thing is when you see this if and only if, that means this result works both ways. You can take this value, you can go to here and say it equals to 0, or you can go and say that the value equals to 0, go back over here and say this is a factor. That's all that means to a whole thing. Oh my goodness, this is going to be so incredibly powerful for us. Now, check this out. What does this mean? Well, this is from your textbook. Okay, look how simple they put it. They says the polynomial in x, p of x, has a factor of x minus a if that p of a equals to 0. Yeah, we know that already. So let's go on with life. Let's take a look at a simple trinomial, something that you factored all the way back into grade 10. And I want to show you some cool stuff. So if you factor this, the old PSA method, do you remember that? Oh my goodness, product sum answer. So your product is 6, your sum is 5. Two numbers, of course, is 2 and 3. So you know and I know this factors down to this and this, 2 and 3. So we can say that, okay, x plus 2 is a factor. In other words, it divides into this very, very easily. Now, if you don't believe me, well, let's take this. X plus 2, let it equal to 0. You get x equals to minus 2, and then let's go out and synthetically divide this. Watch. There's 1, there's 5, there's 6. 1 comes down. 1 times negative 2 is negative 2. Add that together. That, of course, works out to be 3. 3 times negative 2 is negative 6. And look at that. Lo and behold, you got a remainder of 0. And this is in the 1's position. That is in the x position. And look at that. Your other factor is exactly what we determined. But here's the cool thing. Here's the cool thing. We could have taken that negative 2 to determine whether or not it was a factor. Say the heck with synthetic division for a second. I just want to know if that's actually going to be a factor. And I'm going to take that factor of negative 2 and I'm going to substitute it back into the equation. So watch this. Negative 2 squared plus 5 times negative 2 plus 6. Check this out. Negative 2 squared is 4. 5 times negative 2 is negative 10 plus 6. Look at that. 6 and 4 is positive 10. Added to negative 10. This, in fact, is a 0. So if I would have been able to guess this factor just by taking out numbers, just like Try 1, see if it works. Try 2. Oh my God, 2 doesn't work. Let's try -2. Oh, that works. Tells you right away that you could have said, oh, x equals to -2 is a factor. So guess what? X plus 2 is a factor of the original polynomial. Wowee, can you ever do some really, really cool stuff now with this? Let me show you exactly what I mean. So let's go on to this. My question then is, I've given you now a trinomial. Uh-oh, we have a problem here, Houston. I've given you a trinomial, and I've asked you to find out whether or not these values, this, and this, are actual factors of the trinomial. Well, you can synthetically divide. I guess you could, but that would be an awful long waste of time. Watch how fast I can do this. I'm going to just solve, right? This becomes x equals to 2. Let's put into this polynomial a 2. Watch this. So that's 2 cubed minus 6 times 2 squared plus 3 times 2 plus 10. 2 cubed is 8. 2 squared is 4. 4 times that minus 6 gives you minus 24. This adds up to 6. This is 10. Add it all together. Guess what? That equals to 0. Guess what? That tells you x minus 2, yes, is a factor. Look how fast that was. All you got to do is be able to substitute it back into the original formula. You're good to go. Let's do it with this one as well. So this is x equals to 3. Let's try it. Okay, so 3 cubed. We're just substituting back into here. 3 cubed minus 6 times 3 squared plus 3 times 3 plus 10. Okay, so we're going to get 27 here. I'm going to get minus 54 here, plus 9, plus 10. Oh, well, guess what? That doesn't work. That does not equal to 0. So guess what? Not a factor. Okay, let's do this one now. X equals to 0, so that means x equals to minus 1. Pop in minus 1. Minus 1 cubed. Okay, minus 6 times minus 1 squared plus 3 times minus 1 plus 10. Wow, this is going to give us minus 1. That's going to give us minus 6. That's going to give us minus 3. That's going to give us plus 10. Now, check this out here, folks. If we did all of that, look at this. Minus 3, minus 3. What am I talking about? That should be minus 1. Minus 1, minus 1, minus 6, and minus 3 add up to minus 10. Plus 10, that equals to 0. Guess what? That's a factor. And then last but not least, here we go. Let's try with this one. Let's try with this one. X equals to positive 5. And you do it again. Just throw this into this value here. And I'm going to just shortcut you a little bit because I've done this on a scrap piece of paper. And I found out that, yes, this in fact equals to 0. Now, here's the cool thing. I'm going to show you something incredibly powerful now. Okay? So I'm just going to go and I'm going to erase all of this stuff because we don't care about this now. We don't care about the fact that it equals to 0. We've confirmed who is a factor and who is not. By using the remainder theorem, I got to show you something amazingly cool. We know that this didn't work. This one worked. So guess what? That's a factor of this original polynomial. This one worked. So guess what? That's a factor of the original polynomial. And we found out that this one worked. Guess what? That's a factor, oops, minus 5. That's a factor of the original polynomial. But if you look, the polynomial is cubed. X times x times x, guess what? I factored a trinomial just by using the remainder theorem. So therefore, since these guys, all three of these guys, are the factors, your factors are x minus 2, x plus 1, x minus 5. It is factored, baby. Yes, now you're probably saying to yourself, no way, that can't be it. Yes, it is. It's that simple. And you can verify this if you want by going out and saying, okay, let's just FOIL this real quickly. That's going to be x squared. That's plus x minus 2x is minus x. That's going to be minus 2. Now, multiply this by x minus 5. For those of you who remember how to do this, it's called the box method. And the box method is really, really simple. All you got to do is go x minus 5 Brup, brup, yoink, x squared minus x minus 2, and all you have to do is fill in the boxes. This becomes, over here, x cubed. This becomes minus x squared. This becomes minus 2x. This becomes minus 5x squared. This becomes plus 5x. And this becomes plus 10. Add them together. X cubed minus 5x and minus x squared is minus 6x squared. 5x and minus 2x is positive 3x plus 10. Oh my God, it actually worked. Holy smokes. Look how powerful then the remainder theorem is when factoring even something as horrendously large as this. Ooh, hang tough. The best is yet to come.